All right, welcome to the video lecture series on Introduction to Computer Networks. And today our topic is going to be VPNs and firewalls. So first, let us try to understand what VPN stands for. VPN is the short for Virtual Private Network. And what it does is that it creates what we say a logically private network using physically public networks. So basically, we are using the physical network infrastructure that is available for us, which could be the internet, which could be LAN, whatever it is. And then on top of that, we create a logical network which is private for a certain group of users. So typically, VPNs require users to authenticate before they can access the network. And this could be very much related to how you use the virtual machines that is provided to you for your labs, etc. And in all of these cases, there is an option where you can access the university network using a VPN. And the fundamental idea is to create a logical private network, and this network is encrypted so that the privacy is ensured for all the information that is exchanged over the network. So let's say someone from outside in the global network tries to access another remote network using this logically private network, that is the VPN. All traffic that is being exchanged between the host and the remote network will be encrypted. So eventually, this allows a secure connection between these remote parties to remotely connect to local area network. So just to look at a very simple example of the VPN architecture. Um, so we have basically in the middle the part which we are referring to as the physically public infrastructure. And then we have on one end the part of the network that we say is the private network. And this, in this example, could be placed on two ends. And the VPN router, as you can see here, are basically the servers which allow these two ends to connect over the internet using VPN connection, something that we also refer as a tunnel. So the physical network allows a virtual tunnel to be created between these two endpoints controlled by the VPN servers so that the private network components on the two ends can communicate with each other securely using the public internet and also providing a virtually private network. So why do we use VPNs? Let's try to motivate ourselves a little bit further. So first of all, we need VPNs because a private network allows us to isolate ourselves from the remaining network. That means that we inherently become more secure and we can protect our information that is being exchanged over the public network. So this is a form of isolation. On the other hand, another conventional way, traditional way that these private connections were set up were with the use of leased lines. So leased lines were privately leased connections, physical connections that could allow us to connect to other networks. However, they are a bit more expensive because you are actually leasing a physical component of the network, and it does not really allow us to connect to other networks because this is, an individual connection which allows the two parties to connect. However, even though it is very secure, but first of all, it is more expensive, and also it doesn't allow us to connect to other networks if we want to. And it's more expensive to set up and manage in the long run. So, given that we adopt VPNs for our use, we can create a virtually public network which is physically public. So that means that in terms of the physical infrastructure, it is using the physical wires and routers and service providers. All of these are public components, but using that we are creating something for us which is essentially private. And this allows remote users to connect to other locations, which is a private LAN, and to ensure that the intended users are connecting to it. We generally have a form of authentication before they can connect to these VPNs, and eventually they definitely are useful for securing the data transmission between the two endpoints. So there are certain objectives, we call the security objectives for VPNs. And to summarize the security objectives, we can say that, first of all traffic on the secure VPN must be encrypted and authenticated. That means that any information that we pass through the VPN must be protected from the outside world. Next is that the security properties of the VPN must be agreed upon by all the parties in the VPN. That means if two endpoints are communicating with each other over a VPN, both of them should have the common VPN properties to support the encrypted channel over the private VPN network. So this is an agreement of the security properties. Next, we say that there could be no hosts or network nodes outside of the VPN which can basically change any of the security properties of the VPN. In an example, let's say no outside host could interfere in a VPN transmission. They cannot hear or listen to any packets which are being transferred over the VPN, or they cannot look into any packets which are being transferred over the public network because it is a part of the virtual VPN connections. And finally, we say that VPN connections should be reliable, it should be scalable, and it should ensure quality of service. So three properties that should be provided by VPN connections. Reliable means that if I'm trying to connect to a VPN, I should be able to. Scalable means that if there are multiple nodes which are connecting to the VPN server should be able to accommodate the increasing number of nodes. And ensuring the quality of service implies that when we have multiple nodes in a VPN, the quality of service should not degrade for any exchange of information that is happening over the VPN network. So to look at a simple setup, how VPNs might work. So first of all, let's try to see how a connection works without the existence of any VPN. So if we have a user device and we have a service provider, let's say it could be Spectrum or Cincinnati Bell or any other service provider. So the user device connects to the service provider, the ISP, and the ISP provides the connection to the global internet, right? So this is a very basic form of connection without the VPN. However, with VPNs, what we have is that the user device has something that we call a VPN client. So the VPN client is kind of like a software. It's a piece of software which allows the user device to enter into a VPN network and performs all the other operations such as authentication, authorization, all of the things. So the user device uses a VPN client to access the network provided by the internet service provider, and then the internet service provider, with the help of a VPN server, allows access to the rest of the internet. And as you can see, all the connections which exist after the VPN client till it reaches the internet, all of these are encrypted. So The idea is that with a VPN, if you are trying to connect from a user device, you would essentially have a VPN client and a VPN server, and the data is actually encrypted between the client and the server so that the communication could be used in a secure fashion. So, in uh, uh, in the case you are trying to set up a VPN, there are certain requirements that a VPN network incorporates. So first of all, we call this tunneling, and this means that the two endpoints which are connected through a VPN should be able to create and maintain a logical tunnel, which means that uh, even though it is going over a public network, there is a logical tunneling that occurs between these two endpoints. Second is encapsulation, and this means that whatever packet that you're trying to send over the network, the whole packet is encapsulated inside another packet before it is transported over the public network. And the outer packet is then again de-encapsulated at the receiver end. So tunneling and encapsulation works kind of together. So let's say this is the piece of data that I would like to send over the internet, and if I send it out to my VPN client, what the VPN client will do is that it will put it inside a larger um, packet where my data remains inside and protected, and this encapsulated packet is sent over the public network, and eventually when it is received by the destination, the destination would then receive the encapsulated packet, take it out from the encapsulation, and will receive the data that it was initially intended to be sent. So this encapsulation that we have over the original data packet that was being sent from the sender to the destination is what creates this effect of the tunneling. The next requirement is what we call encryption. So that means the sender at one end of the VPN encrypts the data, which can only be decrypted by the other end. All right, and this encryption and decryption process at the two ends allows the information that is being transferred to be secure and private and protected from the outside world. And in terms of the encryption, there are two modes of encryption. We call it symmetric and asymmetric encryption. And different forms of VPN protocols, they actually support both modes of encryption, both the symmetric and the asymmetric encryption. We'll just look at it shortly, what it means, the symmetric and asymmetric, but there are protocols for VPN networks which support both of these versions. The next requirement of VPNs is authentication, which ensures that the sender is actually authorized to use the VPN, which means that whenever a user is trying to join a VPN network, we need to make sure that the user is actually allowed to be a part of the VPN, the private network. And finally, VPNs the overall architecture of VPN should also incorporate what we call the firewall. And a firewall is something that provides general network security by preventing attacks from outside of the private network. And they can actually be placed both in front or behind the VPN server. All right. So let's take a quick look at what symmetric and asymmetric encryption looks like, both of which are supported by different VPN protocols. So first of all, for symmetric encryption, if you're trying to send a piece of data, we first encrypt the data using what we call a session key. And then the data becomes encrypted and something which, if you look at it, you cannot understand what it means. And at the other end, when it is received by the destination uses the same session key to decrypt the data and then is able to view the data in plain text. So in formal terms, we say that the encryption is done using a key, let's call it K, and then we use the same key, K, to decrypt the data. And for symmetric encryption to work, we say that the sender and the receiver must have a separate mechanism to actually share the key. So the key must be shared by both the sender and receiver, and it is a separate mechanism. It would happen before the VPN is set up, or it could be in a physical world where the sender receiver exchange the keys using something else. But both of them must have the same key for symmetric encryption to work. There are certain algorithms, the most common ones for symmetric encryption. We call it the DES, short for Data Encryption Standard. There's also the 3DES, which is a little bit more advanced version, and what it does is that it first encrypts, then decrypts, and then again encrypts DES. So encrypt, decrypt, encrypt, DES. That's why 3DES. And then the other one is AES, in long, short for Advanced Encryption Standard. And the difference between these versions are basically the different length of the keys that it can use. DES uses 56-bit keys, 3DS uses 168-bit keys, and AES uses 128-bit keys. And these keys are basically the length of the keys which are being used to encrypt and decrypt the data. So the next version is asymmetric encryption. And the thing here, which is slightly different, is that the encryption on the data is done with a key that we call the public key. And the public key encrypts the data, and the data then becomes protected and encrypted. So even if you look at it, you will not understand what it means. And then at the receiver's end, it needs to be decrypted, but now the decryption needs to be done with what we call a private key. So the private key, when you decrypt it, after that you will be able to view the data in plain text. So in formal definition, we use a public key, K1, to encrypt the data, and a private key, K2, to decrypt the data. So one thing let me clarify is that the public key is the public part of the key pair for the receiver. So the receiver has a pair of keys, K1 and K2, where K1 is public and K2 is private. And what it means to be public is that the receiver will publish the public key over the internet or publicly, whatever, so that it can be accessed by anyone. So anyone can collect the public key of the receiver. So anyone who tries to send that particular receiver piece of encrypted message, they will collect the public key, which is easily accessible publicly, and then uses that key to encrypt the data. And the receiver never reveals the private key. It is something that it is private to that particular node, the receiver, and then whatever that it receives in an encrypted form, it can use its private key to decrypt and view the data. All right, so this is the difference between symmetric and asymmetric encryption, where symmetric uses the same key for encryption and decryption, and in asymmetric encryption we use two keys, a public key and a private key for encryption and decryption. The common algorithms for asymmetric encryption are RSA and LGML, and both of these are very well known and well supported with most protocols for encryption and also for VPNs. And if you look at the most common VPN protocols, so these are publicly available for use, not proprietary versions. So these are anything, if you have like a Windows machine or a Linux or a Mac machine, most of these machines support these various VPN protocols for a client to join a VPN network. So the first one is point-to-point tunneling protocol, or PPTP. So this is widely supported and fast, and also it provides data confidentiality. So that means it makes sure that the data is protected from anyone who is trying to view the data. This was developed by Microsoft. However, it is available for all operating systems. The next protocol is Layer 2 tunneling protocol. This stands for, in short, it's called L2TP. And what it does is that it combines the point-to-point tunneling protocol, the PPTP, and the Layer 2 forwarding protocols. So in Layer 2, we are working with the data link layer, and the data link layer is a part of the L2TP protocol, and it combines the PPTP protocol to provide both confidentiality and integrity. So here, confidentiality means that anyone from outside cannot view whatever that is inside an encrypted packet. And integrity means that if someone has actually modified the packet, the receiver will be able to identify that the contents have been modified. Even if it is encrypted, someone can actually modify the content so that when it reaches the destination, when you decrypt the content, it doesn't really end up with something that you didn't intend to send in the first place. So it can identify any data tampering that occurred during the transmission, as well as it makes sure that anyone from outside cannot view the contents in plain text. The next protocol is a very well-known and common protocol in network security and also for VPNs. We call it the Internet Security Protocol, in short, very commonly known as IPsec. And the IPsec protocol provides a complete VPN solution by combining multiple protocols. So it's a set of a lot of different components from different protocols, and provides a complete security for VPNs, and it works in the network layer, which is layer 3, right? And this IPsec can actually be used by both point-to-point tunneling protocol and layer 2 tunneling protocol. So both of these earlier protocol that we just talked about can use IPsec as its layer 3 component, because the IPsec is a much more concrete protocol with a combination of multiple protocols working together. Finally, we have what we call OpenVPN. This is an open source VPN software along with an open source protocol for ensuring for allowing VPN connections. And this also provides a complete VPN solution by combining multiple protocols. So this is just the open source version of a lot of other things which are proprietary. And this runs instead of the layer 2 or layer 3, OpenVPN runs in the transport layer, that is layer 4. And we know that the most common protocols for layer 4, the transport layer, are TCP and UDP, where TCP is reliable, UDP is unreliable, and OpenVPN actually supports both the TCP and the UDP datagrams for encrypted channeling through the VPN.